Hello guys, welcome to Coder's Paradise, and in this video we are going to learn about some basic array problems. We will discuss some basic problems in this video, and we will slowly move to the some intermediate and harder questions in a future. So today the question which we are going to discuss and solve is, we have given an array of elements and we need to find the count of elements which has at least one smaller element. I will just explain this with an example. So let's take an example. For example, let's consider one array 2, 6, -1, 4, 5. Okay. So in this array, we need to find that particular element which has at least one smaller element. Okay. So let's pick one element at a time. So let's talk about 2. So does 2 have any smaller element? So yes, -1 is present here. So we have a smaller element. So we can say yes, 2 has. Then we move to 6. So of course, 2 is the only element which 6 has. Okay. And 5 is also, 4 is also there. But yeah, 6 has at least one smaller element. For -1, is there any smaller element than -1? No, we don't have any. So we'll say no. We move to 4 and we check if 4 has a smaller element. Yes, it has. Similarly for 5. So so here the answer will be 4. Okay, like 1, 2, 3, 4, 4. Yes, we have. So answer is 4. Okay. Now let's just discuss how we are going to solve this problem. So if we talk about very basic solution, you can call it as a brute force solution. So it will be like going to each and every element and then iterating over the array and checking if there is any element which is smaller than the current picked element. So if there is a smaller element, we can say yeah, we will increase our count by 1, and we move to the next element and then again iterate the whole array and check if there is any element which is smaller than the current selected element. If yes, then we will increase the count. So let's just write a rough pseudo code for this. You can write this algorithm, whatever we code as a pseudo code, you can code this in any of your choice programming languages, any programming language which you like. So let's just start with that. So we will say, let's take a integer count. Okay, just spell it correctly, count, and keep it as 0. Okay, then we have our we can call our resultant array as an arr. So int array arr will be equal to, let's keep it as the same example, we can keep it here, 2, 6, -1, 4 and 5. Let's take this as an array, and then we will create a loop for int I equals to 0. I is smaller than arr dot length I plus plus. Then what we can do is we can take another variable int current. We will take it as arr of I. This is the current selected element that we are going to select, and then compare this element with the other elements of the array. Then we will create another loop. This loop will, what we will do here, we have selected the element here, selected the element, and now we have to iterate over other elements to check if the current element has any other element which is smaller than the current. Okay, for int j equals to 0, j is smaller than, again, arr dot length and I plus plus. Okay, so we'll check if our current element is greater than arr of j. If that is the thing, we will increase our count. Okay, we will break. We will break. Why we break? We break here because we need at least one element smaller than this. Okay, so if there is any element which is smaller than this, we will kind of a break. Okay, So this way we will increase our count and we will find the total number of, you know, elements which is small, which have at least one smaller element. Okay. Now let's just talk about the time complexity. So what we are doing here is we are iterating, we are having two for loops, one inside the other, and we are selecting one element and iterating over the whole array. So for each element, we are doing n iterations. So for n, we will just discuss like this. So for each element, we are iterating n times. So for n elements, we will do n square iterations. So our time complexity comes to big O of n square, and space complexity is big O of 1, as because we are not using any extra space to store our input array. Okay. Now let's make some observations here. So we can find some observations which is important in order to optimize the solution. So observations. So first of all, we need to think, like, let's suppose we have the array. Let's take our input array. What is it? 2, 6, minus 1, 4, 5. So we have 2, 6, minus 1, 4, and 5. Okay. Now, if I ask you, like, which element in the array will not have any greater element, okay, which will not have any smaller element. Sorry, not greater, it's smaller. So we can say that here the smallest element in the array will not have any smaller element. Okay, no smaller element. So what we can do here is we need to find a smaller element within this array, and then we need to count the number of smaller elements if there is any duplicate, because there might be a chances that minus 1 is the smallest element among this array. Now there can be the chances that minus 1 is repeated many times, like 1, 2, 3, or n times it is repeated. So we need to count the frequency of the smallest element. So let's go step by step. The first step we need to do is find the smallest element, then find the frequency of the smallest element. Then it is not fourth step, it's the third. Then the answer will be equal to size of the array minus frequency of the smallest element, right? This is because we have find, because as we have discussed, that the smallest element of the array will not have any smaller elements. So we have found the smallest element. Now we found the frequency. Then if we subtract the frequency from the size of the array, then we will get all the elements which has at least one smaller element, right? So let's try to write this code. So first of all, we will write a function or a code snippet to find a loop to find the smallest element. Okay. So first of all, what we need to To find the smallest element, to check, we will first of all take our int, the smallest element. Okay, so we'll take the smallest element and we will keep it as array of 0. The first element, we say that we are supposing that first element is the smallest element, then we will start comparing. Okay, so we'll start the loop. You can keep as int max as well here. I is smaller than arr dot length and I. We will check if, so from here we will start with 1. Just a minute. We will check if the smallest element is smaller than, is greater than arr of I. We can say the smallest, we will update our smallest element as arr of I. Okay, now we have from this code we found the smallest element. Now what we will do, we need to find the frequency. So here, okay, frequency. Okay, arr dot length I plus plus. Now we can say if arr of I doubles equals the smallest element, we will increase our frequency. We will take here a int frequency equals to 0. So we will increase our frequency by 1. Okay, now we gonna return our answer will be, our answer that will be the size of the array arr dot length minus frequency. Right? So this is the whole solution. Now we can discuss about the time complexity with this. So what we are doing, we are doing one loop over here, another loop over here. Okay, one loop over here, and it is running n times. This loop is running n times. So we can say that total iterations n plus n, because they are running separate, it will be equal to 2n. Ignoring the constant term, we will get it as n. So our time complexity is big of n, and the space complexity is big of 1, because we are not using any extra space. So hope you guys like this video. If you have any doubts, please mention in the comments. I will be looking through the comments regularly, and in the next video we will again going to solve another problem on the array, and this will be again a basic problem, and slowly we will increase the complexity of the problem, and we will move to intermediate and advanced. So this question we are only kind of using the basic concepts of array, and we are not moving to some other advanced concepts. We are not utilizing in this question. So we are just learning some basic problems, and we can solve the same problem in the upcoming videos with different approaches, with more optimized approaches as well. There will be multiple problems you will see, but yeah, we will move slowly, one step by step. Okay, so thanks for this video. I will be joining back with you with another problem in another video. So make sure you like my video and subscribe the channel. Thanks for watching. For now, bye bye.